Hi there, pre-cal students. This is our last lesson, lesson 15-4, laws of sines and cosines, which one to use. So what we're going to be doing here is just practicing with law of sines, law of cosines again, and really zeroing in on when we use each one. If I have an option, I would much rather use law of sines simply because it is much less complicated. Much easier to use law of sines than law of cosines. Okay? So let's look at, we have three examples here. Let's kind of go through. Number one, we've got angle A is 25 degrees, angle B is 75 degrees, and little a is 14. So if I draw myself just kind of a generic little triangle down here, I'm going to label it A, B, and C. And I've got angle A is 25 degrees, angle B is 75 degrees. And little a, opposite of big A, is 14. And so I need to find little b, I need to find little c, I need to find angle C. Remember that law of sines, we can always use law of sines when we have an angle side pair, which is that's exactly what we have here. I have big A and little a. Anytime I have both A's or both B's or both C's, I can use law of sines. So that's what I'm going to do. First of all, I'm going to end up using law of sines here, but first I can find angle C simply by subtracting from 180. So let's start with that. So angle C is equal to 180 degrees minus these two added together, 25 and 75. So that's 100, and 180 minus 100 would be 80 degrees. So angle C is 80 degrees. All right, so I'm going to find little b. So I'm going to say sine B, sine of 75 degrees over little b, is equal to sine of A, sine 25 degrees, over little a, 14. Cross multiply here, I get B sine 25 degrees equals 14 sine 75 degrees. Divide both sides by sine 25. Make sure your calculator again is in degree mode. And B is equal to 14 sine 75 degrees divided by sine 25 degrees. And also be sure you're rounding to 3 decimals on these lengths. And this is going to be 31.998. I know that's very close to 32, but resist putting 32. It is 31.998. If you put 32 on homework on a problem like this, you will lose points. Okay? Let's find C now. And I'm going to use the A values. I know that I could use B now that I know what little b is, but those are rounded, and I'd rather use exact values. So I'm going to say sine of 80 degrees, that's my big C, over little c, is equal to sine 25 degrees over 14. And so cross multiply, I have C sine 25 equals 14 sine 80. And I divide both sides by sine 25. And little c is equal to 14 sine 80 degrees divided by sine 25. And it turns out that is 32.624. All right? Notice the largest side is opposite the biggest angle, and the smallest side opposite the smallest angle. Okay, let's look at number 2. I've got angle C is 20 degrees, and I've got little a and little b. So let's draw this. I clearly do not this time have a side angle pair. I don't know both A's, both B's, or both C's. And so angle C is 20 degrees here. Here's little a. Actually, so little a is 6, I do know that. Little b is 7, I don't know little c. Okay, so what I have here is I've got two sides and the included angle. I have to use law of cosines in that situation. I must use law of cosines in that situation. And I've got to solve for little c. That's my only choice here. Okay? So let's just do it. I'm going to start just right here below the picture I drew. I'm going to say c squared equals, I'm going to use a squared plus b squared minus 2ab cosine c. That's my formula. So let's plug in. A squared is 6 squared. B squared is 7 squared minus 2 times 6 times 7. Cosine 20 degrees. Alright. C squared is 6.066. And when I take the square root of that, I get that C is approximately 2.463. 2.463. Alright. So now now I know the angle side pair of C. Notice the biggest, since I'm going to use law of sines now, it is possible that if one of these angles were obtuse, it would have to be angle B, because that has to be the biggest angle. It's opposite the biggest side. So I'm not going to use law of sines to solve for angle B. I'm going to use law of sines to solve for angle A. Okay? And that is an important thing, because if B ends up being obtuse, then law of sines will not give you that angle. All right, so let's find law of sines, angle A using law of sines. So I'm going to say sine of angle A over 6 is equal to sine of 20 over 2.463. And here I know I'm using a rounded value, but I don't have much choice. Multiply both sides by 6. Sine A is equal to 6 sine 20 degrees divided by 2.463. And angle A, capital A, is inverse sine of that. Inverse sine of 6 sine 20 degrees over 2.463, which would give us about 56.4 degrees. So there's A, 56.4 degrees. Okay? To find B now, I'm going to take 180 and I'm going to subtract 56.4 plus 20. And when I do that, I'm going to find out that angle B is 103.6. Sure enough, it is obtuse. So using law of sines to find angle B would have been a mistake. That would not have worked very well. It would not have given me that angle. It would have given me an acute angle instead. All right? All right, last example, number 3. And here they're giving me all 3 sides. They are not giving me any angles at all. So let me draw it first. So clearly I don't have an angle side pair since I don't know any angles at all. Little a is 8, little b is 10, little c is 12. So I've got to use law of cosines. And I'm going to use version 2 of law of cosines. And since I'm using law of cosines, I might as well find my biggest angle first. It may be obtuse. Law of cosines will tell me if it is obtuse. So I'm going to say cosine of C is equal to a squared plus b squared minus c squared over 2ab. So cosine C is equal to 8 squared plus 10 squared minus 12 squared divided by 2 times 8 times 10. And I can see that this is the numerator here is going to be a positive number, so I'm not going to get an obtuse angle here since this is going to be positive. And what I end up with is 20 over 160. And so C is equal to inverse cosine of 20 over 160, which would also be 1/8, by the way. And that is 82.8 degrees. So there's my C. 82.8 degrees. And now I do have an angle side pair, which would be, I know both C's. So it doesn't really matter of these other two, which I do. I'm going to go on, let's just do A. So sine of A over 8 is equal to sine of 82.8 degrees over 12. So if I multiply both sides times 8 here, I get sine of A equals 8, sine 82.8. And if you want to be more exact there, if you have that still in your calculator, that might be a handy thing to use sine of that. And so A is equal to inverse sine of 8 sine 82.8 divided by 12, and that comes out to be 41.4 degrees. So A is 41.4 degrees, and again for angle B, I'm just going to subtract from 180. 41.4 plus 82.8, and I get that angle B is 55.8 degrees, which is between these two. Smallest has this small side, smallest angle, biggest side, biggest angle, so that looks good. Okay, that is it. We are done here. Everything is due by Friday. That includes anything you haven't gotten done yet. We need to have it in Friday. I'm grading this weekend. I'm turning in grades on Monday. Monday noon is when I have to have grades in, so you need to have everything to me by Friday, please. Hope y'all are doing well. I hope I see you soon. If not, take care. Have a good summer. Bye.